right, well, welcome to the soils class. My name is Don Rainey.
Sure. Hi, everyone. My name is Golmar Gol Mohammadi. I'm a professor, assistant professor here at Range Cattle Research and Education Center. My program, our research is focused on hydrology, water basically, water quality and quantity. And we do a lot of water quality research about groundwater, surface water. Since I moved here, I used to do hydrology for many years, about 15 years to 20 years. But when I moved here to Florida, I focused on hydrology of grazing lands. Because I do live in Florida, and this is part of my job, to address the issues here. So we are using in our research different type of tools and techniques like modeling, AI. We are not only limited to surface river or groundwater. We do the irrigation management, optimization. I would love to hear from you guys, and if you feel free to reach and discuss any issue that you think you can share with us.
Okay, well, we'll get started. I'm going to briefly show you a PowerPoint of what to expect over here. We got a couple of hands-on projects that we'll do, and learning about soil texture. And to start with, we got to get our fingers right. So let's grab your sleeve, feel it. What does it feel? Describe it. Soft.
Smooth.
Slick, smooth. Okay. All right. You got what?
I said rough, but not uncomfortable.
Yeah. Okay, well, let's describe the carpet. What does it feel like?
Rigid.
Okay, so it's more coarse, right? Well, used to, well, still do, farmers out in the field to determine or check their soil texture, it's by hand. It's by hand. They would grab a ball, wet it a little bit, roll it around, and then start to squeeze it. And as they squeeze it, they could try to push out what we call ribbon. And it basically looks like your dog's tongue or something. It just starts to come out. And then the more clay in it, the longer that ribbon would be. And so we could take and determine texture just by off the feeling. So farmers are great at that. We're not so much, so to speak. We're still inside. So we can use other ways. This is another method of evaluating texture. And we're going to use the triangle today. So what's important to know about soil texture? What would you think
You gotta know what the soil is like, so you know what you can, what you can have on that.
Okay, so the plant selection is critical.
Water retention.
Water retentions, does it need irrigation or not? And it goes back to, what plant are you using? What's the soil? Is it matched up? If not, you have to add some water to it. And then we have components too, and they're all natural. We have the sand, silt, and clay, and organic too matters. Organics is part of that, what I call the mayo or the frosting between the cake layers. It holds all the three components together, and it helps bind and create passageways for either insects or air itself or water too. But we're going to concentrate on the percentages of sand, silt, and clay today, and it's going to help us determine, again, how soil interacts as far as water, air, and nutrient movement. And so the bottom line is, what we need to come away with is that soil texture is going to help to dictate what plant will be selected, and also how will it maximize crop yields. We definitely want to look at that to ensure that what we're planting is worth the cost. And so just to get into the sandy behavior characteristics real quick, you might see this again. Sandy soils regarding water, would you say it retains or drains quickly?
Drains.
It's definitely going to drain quickly. So we have a low water retention capacity, so we're going to have to irrigate that more. So again, knowing what that soil texture is composed of is important regarding irrigation use. Silt soils, they're going to have a smoother texture. Not as much as clay and much more than sand. And they're going to have that ability to retain moisture a little bit more than typically sand, not as much as clay. Clay is an incredibly fine particle, and it's sticky when wet, plastic, so you can determine definitely your soils by again, feel if you do have heavy clay soils. They are prone to waterlogging, so they're going to retain much more water than the other two components. So we're gonna take the jar today, and you'll see this in just a second. Oh, man, I gotta speed up. And so we're relying on gravity to help us today. And how would gravity help us when we put a sample of soil in here, shake it up? What's going on? How does it settle out? Heaviest goes first. That's right. So what do you think the heaviest component is? Sand. So we're going to get fallout with sand first, and then we don't have 2 hours, but we do get some silt to fall out. The clay is definitely going to be there all day. It'll be 24 hours. This is kind of the end product we'll be looking at. We're going to look and determine the percentages based on the colorations, the layers, the stratification here. This milky is the clay particles. They just haven't settled down yet. So we'll have to take a guesstimation on that maybe. And we'll use this triangle to do that. And what we're looking for, the lines will intersect each other. So clay lines, this is your clay. So if you have 50% clay, it's going to run all the way laterally, horizontal across. So you would keep that line. If you had, say, a 20% silt, it's going to run down this way, so you can see where it would cross the clay here. And if you had a 30% sand, it's going to run this way. And I've got a little cheat code to let you know which way. But if it zeroed out there, or say it zeroed out here, it would be a clay up here, a clay type texture. But if it was in here, that's what we're looking for. We're looking for loam texture soils because they provide the most balance in soil characteristics that we desire for plant growth. And so let's do that. Let's divide up in groups.
So we are going to have a practical form of what we have explained here, right? So we are having 2 plastic containers. I will allow each of you to grab one. So we are going to fill these containers with 2 different types of soil, and then try to do something similar to the diagram that we saw. Yeah, but I will do it on the presentation. So one of you can grab this spoon, and then you come here and grab.
Take your jar.
Take the jar with you. So take the water and fill it up to this line. You can put it down. Fill it up.
It's leaking.
Cover it. And cover it tight. Now shake it. Alright.
Shake it, shake it.
Great, that is enough. So we allow it to settle down into the different compositions, right? You can also come and grab the other soil, same procedure. I just want to give you a brief description of each soil particle. According to the presentation, we are having 3 different soil particles. So when you pick your guiding soil is composed of 3 different soil particles. The first one, or you can name what the heaviest among them is sand. And then the second heaviest is silt, and the lightest of the 3 soil particles is clay. So now let's get back to our containers and try to figure out the different compartments or layers within our experiment. If you take a close look, we can figure out 3 compartments right now. From the very bottom to the part where we have a very small ring, black ring around, is our sand. Because it is the heaviest, it settles down first. The black ring you are seeing is our silt, and the remaining portion is the clay, which will take a very long time to settle down. So remember, the silt, the numbers runs down from 10, 20, 30, 40, that is for silt. So for you to determine which lines represent the silt, the lines, the diagonal lines that runs from the bottom to your left represent silts. For clay, the horizontal lines represent clay. And sand, which is at the bottom, the lines that run diagonal but upwards represents the lines for clay soil. Right? So a quick recap. How many soil particles do we have? 3. The heaviest among them is The lightest among them is,
Clay.
and in between we have.
You talk about this.
Thank you very much.
What can you tell us?
Thank you, Maxwell.
You can keep it if you want.